It finally happened. After years of developers begging Meta to do it, they finally accepted to give us developers the access to the camera of the headset. Now, this opens the door to so many cool things that we can now build, like light estimation, visual effect, and of course, using AI on the camera. So I spent days trying to learn everything that I could with this new tool, and I'm so happy to release everything that I learned in 3 videos on the channel. In the first video that you are watching right now, we will learn the basics of accessing the player's camera by creating this cool photo effect. Then, in the second episode, we learn how to do a web request to ChatGPT to create description of the object that we hold. And finally, in the third video, I will show you how to use Unity Scientist to wrap an AI model inside the VR headset that we can use with our camera API. So don't forget to subscribe to not miss the next video. You can get access to the source code of everything on my Patreon and even access exclusive content like my latest tool that I've been working on, which can analyze your project and optimize it in one click. But first, have you guys noticed something different in this introduction? That's right, it is the first time on the channel that I'm making a video standing, and it is all thanks to my new sit-stand desk, the beautiful Flexispot E7 Pro. With its dual motors, the E7 Pro moves up and down like a breeze, no matter how loaded your setup is. It is super stable, with no wobbling at all, and it can handle up to 160 kg, which is 352 lbs for our American friends. To be honest, I wasn't sure I'd like using a standing desk at first, but now I'm addicted. When working in VR, I was so tired of having to stand up every time I needed to test my game. Now I can work standing and jump straight into play mode, so if like me you want to treat yourself, go check out flexispot.com using the link in the description. They've got a super large variety of desktop to choose from. Mine is bamboo, cut 160 centimeters wide, which looks awesome. Big thanks to Flexispot for sponsoring this video. But without further ado, let's get started. Okay, so the first step to use the new pass-through camera API is to go on this GitHub page from the Oculus sample, which you will be able to download in the description down below. Then you can simply download this package as a zip right there, or open it with GitHub Desktop. In my case, I would simply click on download zip. Now, while it is downloading, it is important to see a little bit of the requirement here. Now, keep in mind that here the pass-through camera is very new, and of course, right now it is still in experimental mode, which means that there might be some bugs. Right now, it only works for Quest 3 and Quest 3S devices, and it must be running with Horizon OS v74 or higher. So make sure that the OS of your VR headset is up to date. Okay, so now that the package is downloaded and unzipped, in my case, I can simply open it with the Unity Hub. For this, I'm going to click on Add Project from Disk, and there I can simply navigate where my project is, and once you see the asset folder, you can click on Open. Okay, now I can see the pass-through camera API sample in the list of my project, but right now the editor version is using 2022.3, and I think it would be better to use Unity 6, which actually worked for this project as well. But be careful that not all Unity 6 version works, but I had no issue with these two ones, so Unity 6.39 and 41. In my case, I'm going to select this one and click on Open with Unity 6.39 F1 over there, and there you go, then on Change Version, and now we just have to press on Continue and wait a little bit. Okay, beautiful, the project is now open with Unity 6. We can close here this welcome page right now, and we are now on an empty Unity scene. Now, before doing anything, let's go to File, Build Profile, and here, make sure that Android is selected and is our current platform by simply clicking here on Switch Platform. And now we'll have to wait a little bit again. Awesome, now the active platform is Android, as you can see, so we can close this window and we can get started on our project. Now, by the way, if we go to the folder, you can see that there is here the pass-through camera API sample folder that contains some awesome sample using the camera API, and that we will talk in a minute. But for now, let's start from scratch the pass-through camera setup on this scene right there. The first thing we want to do is select here the main camera and delete it by pressing on the delete key. Now we can go to Meta, Tools, Building Blocks. So the building blocks are like easy things that you can simply drag in your project, which will handle all of the setup and everything for you, which is super easy to get quickly started on a Unity project like we are doing right now. So for example, in our case, we want the camera to be there. And here it is asking us to override the Android manifest. So let's click on override. We can also drag the pass-through. And I'm going to drag also the controller tracking to see the controllers. There we go, now we can close this window. And just for testing that everything is working, we can save the scene with Ctrl S. and we can give a name to the scene. I'm going to name mine Camera API Test. Beautiful. And now if we go to File, Build Profile, here we have a list of all the things that will be contained on the build. And in my case, I'm going to click on Open Scene List. I'm going to select everything and press on Delete to remove it, and only click on Add Open Scene to add the scene that we are currently on right now. There we go. So let's go back to Android. And now just for testing what we currently have and to also show you what's inside the building blocks, let's simply click on Build and Run. Okay, so at this point, this is what you should see. A simple application using the path-through where I can see my surrounding and here my controllers. But of course, right now we can see the path-through, but we cannot use it as a parameters in our game. We cannot access it, we cannot read its pixels, and this is what I'm going to show you right now. Okay, to access the path-through, we can close here the build profile, and I'm going to search in the project for the webcam texture manager, and it's over there. I can drag it in my scene, and as you can see, this prefab contains a very important script, which is here the webcam texture manager, which can turn what the camera see into a texture. We can select which eye we want to use for the camera, and we can set a desired requested resolution. Now, if you set it to 00, it will basically use the maximum resolution, which is what we want. And then we have here a path-through camera permission, which, as you can see, will ask the use scene permission on start. And this is actually something that is like quick bug fixes by here Meta, because it seems that they cannot ask for multiple permission at once. And so their way of doing it is to actually not ask any permission over there on the OVR manager, but add them directly here on the path-through camera permission script. And so to ask the permission directly inside the prefab after the webcam texture manager has done its own permission. Now anyway, now that we can turn the webcam into a texture, let me show you how we can use it by simply displaying it on a quad in front of our player. For this, let's simply right click, go to create empty, and I'm going to rename this game object to path-through camera display. There we go. We can reset its position to 0, 0, 0. And I'm going to add a component, which I will name as well path-through camera display. There we go. Okay, so the first thing that we want to do is go at the top and add using path-through camera sample. This will allow us to actually access the webcam texture. So we can now do public webcam texture manager, and we can call it webcam manager. Beautiful. Now another thing that I want to do is simply get a reference to a renderer, which I will call quad renderer. Beautiful. And in the update function, what we can do is check if the webcam manager.webcam texture is not null, and simply assign now our quad renderer.material.main texture to be the webcam manager.webcam texture. It is as simple as this. And here, making sure that there is a webcam texture on the webcam manager will make sure that everything is well initialized for the webcam manager and that it had the time to basically do all of the permission requests that it's doing at the start of the game. Now, anyway, everything is good. We can save the script, go back to Unity. For the webcam manager, we can simply drag the prefab over there. And for the quad renderer, I'm going to right click, go to 3D object and then on quad, and we can call this one path-through camera quad. For the scale, we can remove the mesh collider because we don't need it. And for the scale, I'm going to set a scale of 1.3. Basically, the resolution of the camera on the Quest is 1280 by 960. So that's why I'm using here the scale, which you can get by doing 1280 divided by 960. And there you go. Yeah, 1.333 is a bit more precise, I assume. Now we can maybe press on R and reduce a little bit the size of the quad as well. And now, just to see a bit better this camera quad, I'm going to drag it as a child of the center eye anchor, which is basically the head of the player. I'm going to reset its position to 0, 0, 0. And I'm simply going to move it a little bit forward so that the camera can see it. Okay, last step is of course to go back to our path-through camera display and drag the path-through camera quad over there. And now everything is down. It is the moment that you've all been waiting for. We can finally build our game to see if we can access the path-through camera. Now, just before doing so, we have something to make sure. The first thing is that, like I mentioned before, we have to disable all the permission requests on startup because everything should be done here with the path-through camera permissions instead. Then if we go to edit, project settings, There you go. If we go to XR plugin management Oculus, make sure that subsample layout is disabled, otherwise it won't work with the camera headset. And now last but not least, if I close this window and that I go to plugin Android, I should see here the Android manifest, which basically contains a list of all the features that we want to use in our game. If we double click on this, we can open it in Visual Studio. Here, very important, make sure that as it is the case already in this application, that you have the permission for the Horizon OS.permission.headset camera. Otherwise, it won't work. Now everything seems good, let's simply go to File and click on Build and Run to build our game. And there you go, as you can see, it is working, it is so trippy. Now, as you can see, the quad is displaying the camera path-through, which really looks great, so that is very impressive. But of course, there is much more thing that we can do than to display it on the quad, so let me show you what else we can build with this awesome webcam texture path-through. Okay, so I just want to modify a little bit the script to, instead of changing here the main texture of the quad to be the webcam texture, instead what I want to do is like create a picture of the webcam texture. And let me show you how I can do this. First, I'm going to create a new function, which I will call take picture. Now on this picture, we can actually get a certain width by doing webcam manager.webcam texture.width. Now that we have a certain width, we can also get a certain height by doing webcam texture.height this time. And now we can actually create a new texture based on what is currently displayed on the webcam manager. So for this, let's go at the top. I'm going to add a private texture to the called picture. And then if the picture is null, what we can do is do picture equals new texture 2D and give the width and height value that we just get. So this is the first time that we'll create a picture, but now we also need to assign the different pixels of our pictures. To do this, we can create like an array of color 32 elements that we call pixels. And if our texture has a certain width and height, it means that it will have as a number of pixel width multiplied by height. Oh, and here it is color 32. So yes, it will have width multiplied by height pixels for a texture that has a width of this and a height of this value. Next, we can get the pixel of the webcam manager by doing webcam manager.webcam texture.getPixels32 and here write pixels. And once this is done, we can simply take our picture texture 2D, do setPixels32 with our pixels parameters. And finally, apply this texture to apply these new pixels. There you go. And now finally, what we can do is actually take this line of code, which is changing the main texture of the quad renderer, paste it over there. But instead of using here the webcam manager.webcam texture, what we can do is use our picture texture 2D, which is a copy of the webcam texture. And there you go. Now, last but not least, what we can do is if webcam manager.webcam texture is not null, and if the player press on a certain button with OVR input.getDown, and in my case, I will use as a button the OVR input button.1, which is the A button. So to sum up, if the player has a texture, and if he press on the A button on the right controller, then we can take a picture. Beautiful. Now our script is done, I think, and we can simply save and go back to Unity. Okay, by the way, a thing that we can do is that right now on the path-through camera quad, the material used is standard, which use lighting, and maybe that's something we don't want. So instead, I'm going to right-click in the project, go to create, and then on material and call it path-through display. Beautiful. And instead of a standard shader, I can go to unlit and then use texture. Now, in the case that you are using not the standard pipeline like I'm doing here, but the URP, the Universal Render Pipeline, you can actually go to Universal Render Pipeline and select the unlit texture as well. It will be exactly the same. Now, let's go back to the quad and assign this new material over there. Perfect. And as you can see now, the path-through display is white. Okay, but now that we've changed here the material to the unlit texture, well, the thing that we just did here won't work because it doesn't recognize here the main texture for the unlit material for some reason. So what we can do is actually go at the top and write public string texture name right there. And now instead what we can do is material.setTexture and give as the name the texture name, and for the second parameters, give the value of picture. Beautiful, now we can save, go back to Unity. And here what's left is to write the texture name that we have on the quad. So to do this, we can go on the right side, click on the three little dots and go to select shader. And here we can see that the texture name is underscore main text. So we can do underscore main text like this. Now we can save, and now it is time to build and run to see how it is looking. Okay, and here we go. As you can see, I have the quad that is completely white right now, but if I press on the A button, ta-da! As you can see, it takes a quick picture of the camera and display the picture directly on the quad, which is awesome. But I want to show you something more that you can do, because with the pass-through camera API, you also get some information about the camera that is directly on the Quest. For example, some characteristic on the camera, but as well as the position of the camera. And that's something that I want to show you right now. And we will actually use it, for example, to position the picture that we are taking right now exactly where it is in my surroundings. Okay, so back into our script, what I'm going to do is first at the start of the game, I'm going to do quad renderer.gameObject.setActive false. There you go. And when we take the picture, I'm going to reactivate it over there so that it won't display a white quad like it was before. Then the next thing I'm going to do is create a new function which will be called place quad. There you go. Now this is where we are going to do some math and use the camera information that we have to place the quad exactly on top of my real environment. So first what we can do is get the transform quad transform by doing quad renderer.transform. Now that it is done, we can actually get the camera pose. So a pose is basically a variable from Unity which contains both a vector3 and a rotation, which is very handy. So we can get this pose by doing pass-through camera utils dot get camera pose in world. So this function get camera pose in world will give you exactly the position of the camera in the world, which is very handy. And we actually need to give as a parameter the camera eyes that we want. And in our case, it is the left eye, which is what we are using for the webcam manager. Now, by the way, if we have a look at what's inside this pass-through camera utils, this is a script from the GitHub project, which contains a lot of cool stuff. For example, you can get the camera in36, which contains some information for the focal length, principal point, resolution, skew of the camera. You can get the pose that we already are using. We can also create an array and more and more. So I strongly encourage you to have a look at this script. It is very handy. But now back to what we were doing before. Now that we have the position of the camera, what I'm going to do is actually get the resolution of the camera by doing pass-through camera utils again. And this time we can get the camera in36 with the pass-through camera eyes left. And now with the in36, you can actually get all sorts of information like I just showed you. And in our case, we just want to show the resolution of the camera. Beautiful. Okay, now that we have this information, I'm going to position the quad in front of the camera by doing quad transform.position equals camera pose.position plus camera pose.forward. And this is where we can actually place the quad at a certain distance of our eyes. So I'm going to put it as parameters. I'm going to say public float quad distance, and we can set it actually to 1, for example. And there we go. Let's multiply the camera pose.forward by the quad distance. And finally, for the rotation, we can give the rotation of the quad to be exactly the rotation of the camera as well, which will align the quad in front of the camera. But now this is where things get a bit trickier. So let me do some drawing for you guys. So if this is our player and this is our camera, and that we are placing the quad in front of the camera, like we are doing with these two lines of code, the last thing we need to do is actually scale this quad to be exactly the size of what the camera is looking at. So in our case, if the camera has a certain horizontal field of view, let's say that this field of view is a value of alpha, what we need to do is actually calculate the length of this triangle right there, which will actually give us like the size of the quad that we are trying to do. And this is a little bit of trigonometry that we need to do. So let me just sums it up for you, because if we cut here this triangle in half, what we get is a rectangle that has 90 degrees. Okay, so if we apply the tangent formula on this triangle, we get that the tangent of alpha divided by 2, which is here the angle of this side of the triangle, then we get that the tangent equal to the opposite side of the triangle, which is L divided by 2, divided by here the adjacent side of the triangle, which is the distance between the quad and the camera. So this is the formula that we want to apply, and if we put it to the right order, we get that the scale of the quad L is equals to tangent of alpha divided by 2 multiplied by d multiplied by 2. And here is our big important formula that will give us the correct size of our quad. So let's apply it directly. But one thing is missing, and it is the value of alpha. So how can we get this value, which is actually the horizontal field of view of the camera? To get this value, we are going to first get the left side point in camera by doing ray left side equals path through camera utils dot screen point to ray in camera. We will give the left eye, and then for the second parameters we are going to give the new vector to int 0 resolution dot y divided by 2. So what this script actually do is create a 3D ray in the camera space, which will start from the left side of the camera, because we are using this value which represents the most left point on the camera texture. Now that we have the left side, we can do the same, but this time for the right side. And instead of here this left position, what we can do is write resolution.x, which is the pixel point on the right of the camera texture. And now we can actually simply get the horizontal FOV by doing vector3.angle left side dot direction right side dot direction. Beautiful. So okay, we have our horizontal FOV. And now what's left is to apply here the formula that I just told you a minute ago by doing float quad scale equals 2 multiplied by the distance, which is quad distance, multiplied by matf.10 for the tangent. And here we can write the alpha value that we found, so the horizontal FOV, and divided by 2. And there you go, this should work, but there is only one thing missing, and it is that the angle that is returned here is in degrees, and the angle that the tangent is using is actually in radian. So what we need to do is actually multiply the horizontal FOV by matf duct to rad. And there you go, this will give us an angle in radian, which is what the tangent needs. Okay, beautiful. Now that we have the scale, we also need to find out the width. And for this, I'm going to create a ratio parameters, which will be picture.height divided by float picture.width. And here is the last step, because what we simply need to do now is do quad transform dot local scale is equals to new vector 3, and simply write here our quad scale for the x value, which we found. And for the y value, we can do quad scale multiply by ratio. And for the z value, value of 1 will be plenty enough. And there you go. This function uses a little bit of math, but it also uses the awesome path through camera utils, which is very handy if you are playing with the camera path through API. Now what's left is to take this function and place it really at the end here after we take a picture, and everything should be good. What's left, of course, is to save and go back to Unity. Oh, and something that I completely forgot before we build and run, we don't want here the path through camera quad to follow the front of our eyes, so let's just drag it outside over there, and it's going to be good like this. Oh, and if you want, for the quad distance, I'm going to set it to maybe 2. I think it will be a bit better. And there you go, everything is good. Now we can just build and run to find out how this is looking. Okay guys, so this seems to be working. I'm going to try to press on the A button, and let's see if the quad is being positioned exactly, well, in front of the object that it should. So if I press on A, ta-da! As you can see, this is a bit trippy. As you can see, it works, and when I press on the A button, it takes a picture, but it also places the picture exactly in front of the object, which is really cool. So at this point, feel free to have a look at the GitHub project, which contains different samples. For example, to use the pass-through camera API pixels for light estimation, or for this awesome color picker. And don't forget to subscribe to not miss the next episode on using ChatGPT Vision with the camera pass-through. Again, a big thanks to Flexispot for sponsoring this video and sending me this awesome standing desk. So if you want to treat yourself and stop having to stand up every time that you test your VR game, go check out their website flexispot.com with the link you will find in the description. Thank you for watching and see you soon. Bye bye.